if substrate groups which has been attached to the carbon chain, it has to be named first, right? And we have to see that to which carbon atom the substrate groups will be attached. In this, halogens are usually electronegative in nature. Since it is electronegative in nature and it forms what? Polar bond. Even though you are using phosphorus pentachloride with the alcohol, we got what? Alkyl chloride. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Haloalkanes and Haloarenes. Under this, we have studied about introduction to the Haloalkanes and Haloarenes, and also we have understood the classifications of Haloalkanes and Haloarenes, and the classifications based upon the number of halogen atom also we have understood. In that, mainly we have studied the classifications of monohalo compounds. Okay. In monohalo compounds, we have understood that there are two types of compounds will be there. The compounds which are containing sp3 hybridized carbon and halogen bond, and we also talk about the compounds which are containing sp2 hybridized carbon and halogen bond. In addition to this, we also discussed about the classifications of dihaloalkanes. Today, we'll step up and we'll learn the remaining topics of this unit by understanding the nomenclature part. Okay, and the nature of carbon and halogen bond in the haloalkanes, and we are going to understand what all the methods will be there to prepare this haloalkanes. Okay, so first we will directly move towards the nomenclature. As we already know that in chemistry, it is very important to understand how to name the each and every organic compounds, right? So as we all have the particular name, like that, each and every compounds in the organic chemistry, it has its own name. And naming of such organic compounds, we call it as what? Nomenclature. Okay. And in this nomenclature of the haloalkanes and haloarenes, we are going to understand that how to the aliphatic carbon chain or to the aromatic carbon ring, this halogen atom which has been attached to form a haloalkanes and haloarenes. Okay. First, we will see with the some of the examples along with the common name and along with the IUPAC name. So here I have a first example of CH3CH2Cl. Okay, and the common name of this compound is, there are two carbon atom, hence it is ethyl chloride. And coming into the IUPAC nomenclature, it is nothing but a chloroethane. Why it is ethane? Because there are only two carbon atom will be there, hence it is chloroethane. You can remember this structure also like this. This is H, H, H. This is chloroethane. Next, we have one more example. This is CH3CH, Br and CH3. And the common name of this compound is Isopropyl Bromide, or you can say it is secondary propyl bromide, and the IUPAC name will be 2-bromopropane. How to name with the 2-bromopropane? I can rewrite this structure as CH3CH, Br and CH3. So we all know that if substrate groups which has been attached to the carbon chain, it has to be named first, right? And we have to see that to which carbon atom the substrate groups will be attached. We know that here this Br is my substrate group and it has been attached to the second carbon atom, right? So it is 2-bromopropane. Why it is propane? Because you can see that there are only 3 carbon atom will be there. So it is 2-bromopropane. Coming into the third example, CH2 double bond CH and CH2 Cl. Common name is Alkyl Chloride. Coming into the IUPAC nomenclature, CH2 double bond CH and CH and H and Cl. Okay. This is CH2 double bond CH, CH2 Cl. You can see that this is 1, 2, 3, right? To the third carbon atom, we know that this chloride group will be attached. Again, it is my substrate group. So, it is 3-chloro. How many carbon atom will be there? 3. So, since we have a double bond, it is 3-chloropropene. You can see that it is 3-chloropropene. How does 3 comes? You can see that this is a third carbon atom where to this substrate group which has been attached. So, it is 3-chloropropene. Next, we have aromatic haloalkanes. So, you can see that we have CH3Cl and Cl. You can see that common name is 2,4-dichlorotoluene, and IUPAC nomenclature will be goes like this. It is 2,dichloromethane benzene. I can rewrite this structure also like this. CH3 Cl and Cl. Now you count the number of carbon atom. So it is 2,4. You can see that to the second and to the fourth carbon atom, this chloro group will be attached. So it is 2,4. How many chloride group which has been attached? 2. So it is 2,4-dichloromethyl benzene. You can see that this is the first carbon atom. So it is 2,2-dichloromethane. We have a last example, CH3CH2CH ClCH3. It is also known as what? Secondary butyl bromide, and you can rewrite the structure also like this. CH3 CH2 CH and Cl and CH3. So, this is the first substrate group which has been attached to this carbon atom 1, 2, 3 and 4, right? So, it is 2-chlorobutane. Why it is butane? You can count that there are 4 carbon atom will be there. So, since it is a butane, since which consists of 4 carbon atom, we have to use a prefix called as butane. And you can see that all the carbon atom, they have a single bond between them. Hence, it is a butane, and the substrate group is chloro, which has been attached to the second carbon atom. Hence, it is 2-chlorobutane. Next, we have CH3 thrice CH2Cl. And how to rewrite the structure? You can see that CH3 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 C Cl. Okay, CH3 CH2 Cl. So you can see that this is the first carbon atom and this is a second carbon atom. To the first carbon atom, again this is my substrate group which has been attached. So it is 1-chloro. To the second carbon atom, you can see that there are 2 methyl group which has been attached. Is it right? So it is 1-chloro 2,2-dimethyl. How many carbon atom will be there now? 3. So it is 1-chloro 2,2-dimethyl propane. Okay. We have one more example. CH3 3 times CBr, and you can write the structure as CH3 and CH3Br. Okay, this is a first and this is a second carbon atom. So it is 2 bromo, or you can say it is 1 bromo 2 methyl propane, or you can say it is 1 or 2. Okay, it is 2 bromo 2 methyl propane. Why it is 2-dimethyl propane? You can see that there are two substituent group which has been attached. Okay. Next we have CH2 double bond CH and Cl. It is known as what? Vinyl chloride, and a common name will be, you can see that there is a presence of double bond, hence it is an alkene. You can see that it is having a one of the substituent group, it is chloroethene. Why it is ethene? Because only 2 carbon atom will be there, so it is ethene, and since it is having a double bond, we have to use a prefix called as ethene. Next, coming to the second example, CH2CH CH2Br, and the common name will be allyl bromide, and you can see that it is 1, 2 and 3. It is 3-bromopropane. Why it is bromopropane? Again, here to the third carbon atom, we have a substituent group known as bromine, and it has been attached to the third carbon atom. Hence, we have to use a prefix called as 3-bromopropane. Next, we have benzene ring with a Cl and CH3, and it is known as what? 2-orthochlorotoluene, and it can be named as 1, 2, 3, 4, 5 and 6. 1-chloro-2-methyl benzene. 1-chloro-2-methyl-benzene, or you can say that it is 2-chlorotoluene. Okay. Next, we have CH2Cl, and it is known as what? Benzyl chloride, and the common name is known as what? Chlorophenyl methane. Why it is chloromethylphenane? You can see that this is a chloro group and it is having a benzene ring. So it is chlorophenyl methane. Next we have CH2Cl2. It is known as what? Methylene dichloride, or you can say that methylene chloride also. And in IUPAC name we say that dichloromethane. Dichloromethane. Next we have CHCl3. We know that this is an chloroform, common name, and in IUPAC name we say that how many chlorine group will be? It is there 3. So it is trichloromethane. Coming into the CHBr3, it is bromoform and it is tribromomethane. Okay. Next is carbon tetrachloride and it is known as what? Tetrachloromethane. Next, CH3, CH2, CH2 and F. It is known as N-propyl fluoride, and in IUPAC nomenclature we say it is 1, 2 and 3. So it is 1-fluoropropane. Why it is propane? You can see that only 3 carbon atom will be there. So it is propane. And we have benzene ring with the bromine as one of the substituent group. So it is bromobenzene, or you can say that 1-bromobenzene. Okay. Coming into the last example, M-bromobenzene or meta-bromobenzene. Why it is meta? To the meta position, bromine group which has been attached. Hence it is meta-bromobenzene. Coming into the IUPAC nomenclature, it is 1, 2, 3, 4, 5, 6. To the first and to the third position, the bromine group which has been attached. So it is 1, 3 dibromobenzene. This is how we will do the nomenclature of haloalkanes and haloarenes. Next we have last examples. See, benzene ring which consists of 3 bromine group and it is named as 1, 3, 5 tribromobenzene. 1, 3, 5 tribromobenzene, and the common name will be tribromobenzene only. And we have CH3CH and Cl2. It is known as what? Ethylene chloride, or you can say that it is a jump dichloride. Dihalide it is, and it is named as what? 1, 1 dichloroethane. You can rewrite the structure also like this: CH3 CH and Cl, right? So it is 1 and 2. So to the first carbon atom, you can see that there are two substrate groups are attached. Hence it is 1, 1 dichloro. Why it is dichloro? Because two substrate groups are same. Hence it is dichloroethane. Okay. Next we have CH2. CH2 at Cl. It is known as what? Vicinal Dihalide, because you can see that two halogen groups are attached to the two same halogen groups are attached to what? Two different carbon atoms. Okay. And IUPAC nomenclature will be goes like this. Before that, I shall rewrite this structure also like this, so that you will understand that what is that vicinal dihalide. You can see that this is a structure of CH2 and Cl. You can see that this is our first and this is the second carbon atom. Even though it is different, the same halogen group has been attached. Hence, it is an example for vicinal dihalide, and the naming will be goes like this. It is 1, 2 dichloroethane. Okay, this is how we will name the organic compounds in a haloalkanes and haloarenes. Next, we have the nature of carbon and halogen bond in the haloalkanes and haloarenes. We know that generally we represented the carbon and halogen bond by C and X. We know that C stands for carbon and X stands for halogen. And these halogens are usually electronegative in nature. Since it is electronegative in nature and it forms what? Polar bond. The nature of this bond is polar. Why it is polar? Because these halogens are more electronegative. Since it is more electronegative in nature, it forms a polar bond. So it means to say that the haloalkanes and haloarenes, which forms a carbon and halogen bond, and such bonds are polar in nature. And you can see that how it is known as polar bond. We know that the carbon in this haloalkanes, which is having more tendency to share its electron towards the halogen. Hence, these electrons will be somewhat pulled towards the halogen, so that halogens are accepting the electron. Hence, it is getting the partial negative charge. Since carbon is donating its electron, hence it become what? Partial positive charge. So that is why this nature of the bonds will be polar in nature, and size of the halogens based on their electronegativity will be goes in this order. More electronegatives is iodine and the least electronegative is fluorine. Okay, fluorine, chlorine, bromine, iodine. And the carbon and halogen bond length, which also in this order, that is carbon and iodine bond order will be more, bond length will be more as it is compared with the carbon and chloride, as it is also compared with carbon and fluorine. So this indicates that the bond length between the carbon and with iodine is more longer as it is compared with carbon and with the fluorine. Next, we have the method of preparations of the haloalkanes and haloarenes. First, I will go with the important method known as from the alcohols. So, by using alcohols, how we can prepare the haloalkanes, we will understand first. Okay. So, by using what? Halogen acids. When alcohols are treated with the halogen acids like dry HCl or with HBr or HI in presence of anhydrous zinc chloride, alkyl halides will be obtained. So, first of all, we must know that what are the halogen acids. Halogen acids are nothing but HCl, HBr and HI, that is hydrogen iodide, hydrogen chloride and hydrogen bromide. Okay. So, these are known as what? Halogen acids. When it is treated with an alcohols in presence of anhydrous zinc chloride, so what will happen? This OH and X will be removed in the form of water, and this halogen which goes and combined to the R group, thereby it forms a haloalkanes. Okay, so we'll take one example by replacing the R with CH3. Okay, so I'll replace the R with what? CH3. I'll replace the halogen with the fluoride, bromide or iodide. You can replace it. I'll take the example of CH3OH. Okay, this is my what? Methyl alcohol. Methyl alcohol, which has been treated with what? Halogen acids. I'll go with HCl. Okay, so in presence of what? Zinc chloride and that too anhydrous zinc chloride. So what will happen? This OH and H will be goes out in the form of water molecule, and the CH3 combines with the Cl to form what? Chloromethane. It is chloromethane. So this is a end product. Remember, when we are dealing with an alcohols with the halogen acids, the product should be the haloalkanes, where you can see that there is a carbon and halogen bond which has been formed. Okay, so this is how we can prepare the haloalkanes by using the alcohols and also by using what? Halogen acids. The alkyl chlorides are obtained by treating with an alcohol with a dry HCl in presence of anhydrous zinc chloride. This reactions, which is also known as what? Grooves reaction, and the mixture of this HCl with the anhydrous zinc chloride, which is known as what? Lucas reagent. So this can be asked for 1 mark. So what is Lucas reagent? Can be asked for 1 mark. So it is nothing but a mixture of HCl with what? Anhydrous zinc chloride, and this is known as what? Lucas reagent. So for your 1 mark, they can ask you this question. Next we have, by using phosphorus halide, how we can prepare the haloalkanes. Phosphorus halide, in the sense, it may be of 2 types. It may be phosphorus trihalide or phosphorus pentahalide also. Okay, so first we will go with the phosphorus pentahalide. We'll see what will be the product. Again, we are taking the alcohols which has been treated with phosphorus halide to form a alkyl halide. Okay, so first I'll go with the phosphorus pentahalide. The chloroalkanes are obtained by treating the alcohols with the phosphorus pentachloride. So this is a alcohol general formula, that is ROH, which has been treated with phosphorus pentachloride. Again, what will happen? This R combines with one of the Cl to form RCl, and this is a alkyl chloride we obtained, and you can see that we have phosphorus with the OH and remaining Cl will be there. So phosphorus with the oxygen and 3 Cl will be goes as POCl3, and we got an HCl by combining with one more Cl to form a HCl. Okay, we'll take up one more example. Again, I'll replace the R with CH3, and we are using what? Phosphorus pentachloride. So it is CH3OH in presence phosphorus pentachloride. So what will happen? Again, the CH3 combines with the one more Cl to form what? Alkyl chloride plus POCl3 plus HCl. So again it is chloromethane and it is methyl alcohol or methanol, you can say. Alcohol and it is chloromethane. Even though you are using phosphorus pentachloride with the alcohol, we got what? Alkyl chloride. Okay. Next, we'll see with the phosphorus trichloride. So, haloalkanes are obtained by when a primary alcohols has been treated with phosphorus trihalides. Okay. So this is a ROH. This is an alcohol which has been treated with what? Phosphorus Trihalide. Again, R combines with one more X to form a RX, and remaining this H, because 3H and O will be there. So it forms a S3PO3, that is phosphoric acid, where halogen can be, X can be replaced with chlorobromide iodo. So again I can rewrite one more example by taking R as CH3 and here X will be considered as a Cl. So how we can rewrite the reaction? CH3OH plus PCl3. So it forms what? CH3Cl plus H3PO3, and again it should be balanced. So again it is methyl alcohol. Again it is chloromethane. You can take the one more example by writing with CH3CH2OH also. PCl3, okay, it is ethyl alcohol, so it is CH3CH2Cl plus H3PO3. So it is ethyl alcohol and it is chloroethane. Chloroethane or ethane chloride, you can say. This is how we can write the reaction by considering the general reaction. Once you know the general reaction, how to write with this, it's very easy to write by taking the R with any alkyl group. Next we have bromohaloalkanes are also obtained by the reaction of alcohols with a mixture of red phosphorus with the bromine. Okay. So how to write this reaction? See here we have a alcohols which has been treated with red phosphorus in presence of what? Dihalogens to form what? RX. So how we can rewrite this reaction? By considering again R with the CH3 or you can say C2H5. You can take anything, C2H5. So I'll go with the CH3 first. So CH3OH in presence of what? Red phosphorus. Okay. And also I'll take the halogen as Cl2 or you can take bromine also. I'll go with the bromine Br2. So what does it forms? It forms CH3Br. Okay. So this is bromomethane. Next we have by using thionyl chloride. Alkyl chlorides can also be obtained by heating the alcohols with the thionyl chloride. Remember, thionyl chloride will be represented as SOCl2 in presence of pyridine as a catalyst. We'll see with the general reaction first. Okay. So this is of the alcohols which is allowed to react with what? SOCl2 in presence of pyridine as a catalyst. Again, what does it happen? R combines with one of the Cl to form a alkyl chloride. Again, this sulfur will combines with one more oxygen to release a HCl, SO2 gas, and one of the remaining HCl, Cl combines with H to form a HCl. We'll take up a reaction by considering the R with CH3. Okay, so it is CH3OH plus SOCl2, that is thionyl chloride, in presence of pyridine as a catalyst. What does it happen? This CH3 combines with the Cl and another hydrogen combines with remaining Cl to form a HCl, and oxygen combines with one more oxygen to release a sulfur dioxide gas. Or you can take CH3, CH2OH also. This is ethyl alcohol which has been treated with thionyl chloride in presence of pyridine as a catalyst. what does it happens? So it forms what? CH3, CH2, Cl plus HCl plus SO2 gas will be released out. Okay. So again this is chloroethane and this is chloromethane. Next is by halogen exchange method. Remember, this is a method where it involves the exchange of halogen. So already by using an alcohol, how we can prepare a haloalkanes, we have understood. Just by exchanging the halogen, how we can prepare the haloalkane, we'll understand first. First, I'll go with the Fringesteen reaction. Again, this is very important reaction. Most of the time it has been asked for 2 to 3 marks. Alkyl iodides are prepared by the reaction of alkyl chlorides or bromide with the NaI, that is sodium iodide, in dry acetone. These reactions are known as what? Fringesteen reaction. So, while understanding all this method of preparations, I have used only the chloro as well as with the bromo as their halogen atom. The remaining, the fluorine and iodine, can be prepared by using this halogen exchange method. Okay. So first I'll go with the alkyl chloride by considering what? Alkyl chloride only. So we have to take halogen group as a chloro or bromo. I'll go with the R by considering with the CH3 and X as a Cl. So it is CH3Cl, that is chloromethane in presence of sodium iodide. So what does it happen in the presence of what? Dry acetone. Just it is the exchange of what? Halogen. So sodium combines with the Cl to form what? Sodium chloride, and this CH3 combines with iodide to form a CH3I. Again it is an haloalkane. You can see that there is a carbon and halogen bond will be there. Okay. So this is a example of alkyl iodide. It is an iodomethane, you can say. Iodomethane. Okay. The sodium chloride and NaBr thus are precipitated in a dry acetone. This facilitates the forward reaction. So here the end product as we got as sodium chloride. If you rate the same reaction by considering CH3Br, that is bromoethane with sodium iodide in presence of dry acetone. Okay. Again, there is an exchange of halogen. So, NaBr and CH3. Again, this is a iodomethane. This NaBr and sodium chloride both can be precipitated during the reaction in presence of dry acetone, which facilitate the reaction to go in the forward direction. Okay. Next, we have Schwartz reaction. Again, it is very important. It can be asked for 2 marks. Okay. So, alkyl fluorides. So, in the Fringesteen reaction, what we are preparing? Alkyl iodides we are preparing. Here, we are preparing what? Alkyl fluorides. Okay. So, alkyl fluorides are prepared by heating an alkyl chloride or bromide in presence of metallic fluorides such as silver fluoride or mercury fluoride or cobalt fluoride or with the SbF3, and the reactions are known as what? Schwartz reaction. So you can see that RBr, that is alkyl group with the bromine in presence of AgF. Again, there is an exchange of halogen will be taking place. Silver combines with the bromine to form a silver bromide, and R combines with the F to form a alkyl fluorides. Okay. Again, we will take up the reaction by taking R as CH3 and X as a chlorine or with a bromine. Okay. Chlorine or with a bromine. So, CH3 Br with a AgF. What does it form? it forms silver bromide with what? CH3F. This is alkyl fluoride. Okay. So this is an example of alkyl fluoride preparation by taking silver fluoride. So remember the Schwarz reaction as well as Fringesteen reaction, both the reactions which involves the preparation of alkyl iodide and alkyl fluoride, which cannot be prepared by using alcohols. Okay. Next we have by Frinell-Craft halogenation. All these reactions we already studied in our first PUC, right? So the free radical chlorinations or brominations of alkanes give a complex mixture of haloalkanes. So here I have CH3, CH2, CH2 and CH3. It is then butane because it consists of 4 carbon atoms, right? So if you take the butane and if you pass an UV light and if you heat it, we got a mixture of 2 compounds, okay? One it is 1-chloro-butane and we have one more product 1, 2, 3, 4, okay? It is 2-chloro-butane. We got what? Mixture of 2 compounds. The first one is 1-chloro-butane, second one is 2-chloro-butane. So in the next class, we are going to understand more about the physical and chemical properties of this haloalkanes and haloarenes. By this, I wind up my session here. So go through with the Fringesteen and Schwarz reaction, which is very, very important from the method of preparation. We'll meet you with the next session. Till that, take care. Be safe. Thank you.